potential difference. Potential in electrical science has the same relation to electricity as pressure in hydrostatics. When pressure difference is maintained, liquid flow from high level to low level. And temperature in thermodynamics, when temperature difference is maintained, heat flow from high temperature to low temperature. Similarly, potential difference causes the flow of charge, that is current. Positive charge flow from higher potential to lower potential. This is the significant meaning of potential or potential difference. To discuss the potential difference or potential, first we discuss about electric field. We know that a charge Q exert electrostatic force another charge Q naught. This force is known as electrostatic force or Coulomb force, and this is inversely proportional to square of distance. Clear that when distance increases, this force decreases. Therefore, there is a field, there is a region, there is a space around a charge till where another charge experiences electrostatic force. This region or space is known as electric field. If a charge is placed in this field, it will experience electrostatic force. If this charge is allowed to move against the electric field, work has to be done. So, mathematically, potential difference between 2 points, say A and B, in electric field is defined as work done in moving unit positive charge between these points against the electric field. Suppose a charge Q naught, which is known as testing charge. As you know, tester is used to check the electric current. Similarly, to check the presence of electric field, a charge is used, very small charge, which is called testing charge. Suppose a testing charge Q naught is brought from B to A against the electric field. W work is done. This work for unit charge is known as potential difference between these points. Again, mathematically, we can say potential difference between the 2 points in electric field equals to the work done in moving unit positive charge between these points against the electric field. Unit of work is joule. Q is Coulomb. That is volt. Now from this formula we can explain electric potential. At infinite, that is B is at infinite, then VA minus V infinite W upon Q naught, or VA is equal to W upon Q naught. So in my opinion, potential at any point may be defined as work done in moving unit positive charge from infinite to that point. In other words, potential at any point is nothing but potential difference between this point and infinite. Now, one important definition: define 1 volt. Define 1 volt. If W is equal to 1, Q naught is equal to VA minus VB is equal to 1. W is equal to 1 joule, Q naught is equal to 1 coulomb, VA minus VB is equal to 1 volt. Definition of 1 volt is: if 1 joule work is done in moving 1 coulomb charge between 2 points A and B, then potential difference will be 1 volt. Or 1 volt is defined as work done in moving 1 coulomb charge between the 2 points if 1 joule work is done. Now, some important question related to potential difference. Example 1. Potential at A is 10 volt. If 10 joule work is done in bringing 1 microcoulomb charge from B to A against electric field, then find VB. Very simple. VA minus VB is equal to W upon Q. VA 10 volt, VB have to be determined, W 10 joule and Q 1 microcoulomb. VB is equal to 10 minus 10 into 10 to the power 6. Volt. Very simple volt. Potential difference between 2 points is measured by a device known as voltmeter. Second question, calculate the potential difference between the terminals of battery if 100 joule work is required to transfer 20 coulomb charge from one terminal to other terminal. VA minus VB, you can write delta V. W is given 100 joule in transferring 20 coulomb charge. 20 coulomb charge. that is 5 volt. Very simple question. Now I will provide you more questions related to potential difference and quantization of charge in my assignment. First you will do this assignment and you can ask with me. Now electric current. Electric current. This is the part of current electricity, that is charge in motion. Students, current is a general word. If motion along a particular direction, then it is said that current is flowing. For example, if some students are moving in a particular direction, then it is said that student of current. Some ants are moving in a particular direction, then we say current of ants. Water flow in a particular direction, this is the current of water. If charge flow in particular direction, this is the current of charge, that is electric current. Mathematically, electric current defined as rate of flow of charge. If Q coulomb charge flow in t second, then current will be Q upon T. Q means coulomb, T means second, coulomb per second means ampere. Unit of current is ampere. Direction of current, direction of electric current, not current. Electric current is considered opposite to flow of electron, that is flow of electron, that is in direction of flow of positive charge. इलेक्ट्रॉन के मोशन के डायरेक्शन के अपोजिट कंसिडर की गई है और पॉजिटिव चार्ज की डायरेक्शन के अलोंग कंसिडर की गई है. सो इट इज आल्सो नोन एज कन्वेंशनल करंट. इलेक्ट्रिक करंट इज आल्सो नोन एज कन्वेंशनल करंट. इफ इलेक्ट्रॉन्स आर मूविंग देयर, ये इलेक्ट्रॉनिक करंट हो गई, इलेक्ट्रॉनिक करंट. एंड इलेक्ट्रिक करंट दैट इज कन्वेंशनल, वो इसके अपोजिट होगी. तो इलेक्ट्रिक पोटेंशियल, अगेन रिवाइज, इलेक्ट्रिक पोटेंशियल is the work done in moving unit positive charge from infinite to a point in electric field. Electric potential difference is work done in moving unit positive charge against the electric field from one point to other point. Formula VA minus VB or delta V is equal to W upon Q. W unit work, Q unit coulomb, joule per coulomb is the unit of electric potential or potential difference, or joule per coulomb is known as volt. If 1 joule work is done in moving 1 coulomb charge between the 2 points, then the potential difference will be 1 volt. After that, electric current. Current is general word. Current may be current of water, current of ant, current of student, and so on. But if charge flow in particular direction, this is the current of charge. that is electric current. Mathematically, it is defined as rate of flow of charge. I is equal to Q upon T. Q means coulomb, T means second, coulomb per second, 1 ampere. Now you can also write as I is equal to NE upon T. Q is equal to NE. One question arises, define 1 ampere. As defined 1 volt, now define 1 ampere. If Q is equal to 1, T is equal to 1 second, current will be 1 ampere. Hence, if 1 coulomb charge is flowing in 1 second, then current will be 1 ampere. It also can be defined as I is equal to 1, T is equal to 1, 1 is equal to NE upon 1, that is N is equal to 1 upon E, 1 upon 1.6 10 power minus 19, 6.25 10 to the power 18. Now in terms of electrons, if 6.25 10 to the power 18 electrons are flowing in 1 second, then this flow causes a current of 1 ampere. In different materials, motion of different types of particle causes electric current. For example, in electrolytes, you know electrolytes? Aqueous solution of salt or aqueous solution of acid or aqueous solution of base known as electrolytes. In electrolyte, electric current flow due to the both types of ions, positive ion and negative ions. In conductors, current flow due to the motion of free electron. In semiconductors, current flow due to the motion of electron and holes. About holes, you will study in next class.